Hi students, welcome to the next session of units and measurements. I think today we are going to enter the PU part. So yesterday we discussed about dimensions, dimensional formula, dimensional equation. So I gave some examples there. In last 2-3 minutes we discussed. Again that one we are starting from first onwards very clearly. So we will be having 7 fundamental physical quantities. Symbolically and representation of those 7 fundamental physical quantities whenever we are writing in the form of dimensional formula. Those you should come to know first. So what is the first fundamental physical quantity we discussed? Length. So whenever length is coming, length means height, breadth, radius, diameter, all will be coming under length. Always length is denoted by capital L. Whenever we are representing in the terms of dimensions, dimension formula, dimensional equation. Next, mass. Mass is denoted with capital M. Next, time. Time is denoted with capital T. Next. So what is the fourth one? Current or temperature. Anything you can take, temperature. Capital K, sometimes they will write with theta. So temperature representation either capital K or theta. Next, current. So electric current. Electric current is denoted with A. Sometimes they will denote with, in some books, they will denote with I. Generally they will denote with A. So many are 1, 2, 3, 4, 5. Next, remaining amount of substance. Very rarely it will come. Amount of substance, it is represented with MOL. Next, luminous intensity. This won't come. Luminous intensity. So I also did see the dimension formula with this candela. CD. So these are the symbolical representation of the all 7 fundamental physical quantities. Now, if you have taken any physical quantity, all the physical quantities will be depending on all these 7. Why? Because these are fundamental. Because any physical quantity is depending on these fundamental physical quantities. That is mass, like time, temperature. So, how we will write the dimensions, dimensional formula, dimensional equation. First, what is meant by dimension we will see. So now I am going to measure height of the surface, height of the wall, or I am going to measure radius of the circle or diameter of the circle. Okay. So whenever we are going to measure diameter or radius, I am going to measure radius of a circle. Otherwise, diameter. So diameter, radius, it is going to be represented, it will be coming under length. Therefore, how we will represent means like this. So, to represent a physical quantity diameter or radius, we have written a fundamental physical quantity length and its power is raised up to 1. This 1 is the dimension of the length to represent diameter. So, dimension of the length to represent the diameter means, what is the definition means? Up to what powers? So, base quantities or fundamental physical quantities should be raised. Up to what powers? Base quantities or fundamental physical quantities should be raised to represent a physical quantity is called dimension. So, if you want to write distance or displacement, distance and displacement also it is will be coming under length. Therefore, L power 1. So generally whenever we are writing in terms of m and t, they will write. So L power 1 means m power 0, L power 1, t power 0, remaining also power 0 we can write. So m power 0 means 1, t power 0 means 1. Generally they will write with m and t. Now diameter symbol or radius symbol we have to write. Radius is r, small r, diameter is d is equal to m power 0, l power 1, t power 0. So this formula is called dimensional formula. This equation is called, equation means LHS and RHS will be there. This equation is called dimensional equation. Okay, so the formula or the expression which is representing physical quantity in terms of powers by raising powers. Okay, so this formula we are saying dimensional formula. This expression we are saying dimensional formula. This equation we are saying dimensional equation. Okay, they will ask write the dimensional formula or write the dimensional equation. Okay, so they will ask at the time very simple how to write. When you can write very easily without remembering or without by hearting also, I will say, so you can't by heart all the dimensional formulas. Okay, this is ready. Next, what you get in another physical quantity you can recall on velocity, because in motion straight line, motion plane, you are familiar with velocity, acceleration and all this. Okay, so we will write velocity. So velocity is physical quantity, derived physical quantity. Derived physical quantity means it is depending on fundamental, isn't it? Derived physical quantities means the quantities which are depending on fundamental physical quantities. So velocity definition: displacement by, and displacement will be coming under length. Time will be coming under, it is represented by t. So L t power minus 1. So to represent velocity, so we should write the power of the length to 1. Power of the time to minus 1. If we represent length power to 1 and time power to minus 1, we are getting velocity. So in terms of dimension formula, we will write like this: m power 0, l t power minus 1. You should call like this: m power 0, l power 1, or l t power minus 1. T minus 1 you should not call. T minus 1 is different. This is t minus 1. So you should not call like this: t power minus 1. So m power 0, l t power minus 1. This is called velocity dimensional formula, dimensional equation. Or simply they will write l t power minus 1 because m power 0 is 1. So velocity is l t power minus 1 means speed also l t power minus 1. Next, area we wrote yesterday. Area. Capital A is equal to what we got yesterday? Length into breadth. That is nothing but L square. So area we have to write in closed brackets. Here right side equation also we should write in closed bracket. This is the representation of dimension formula: m power 0, L square, t power 0. This is the dimension formula for, or dimension equation for area. Next, volume. So volume is equal to length into breadth into height. Length into breadth into height means all will be coming under length. So L into L into L. That is nothing but L cube. That is the dimension formula for volume. And what is the dimension formula for mass? Mass is denoted with small. LHS is mass, right? RHS. Mass is denoted with capital M. Yeah. So mass power, fundamental physical quantity power rising to 1, then we are going to represent the mass. If you want to write like this: m power 1, l power 0, t power 0. So next, any other physical quantity you can say this is volume, not velocity. Volume. Next, acceleration. Acceleration is denoted with a, small a. What is acceleration definition? Velocity by time. At the time, you should come to know what is velocity and time. Dimension formulas. Velocity dimension formula. Velocity dimension formula already we got. L t power minus 1. L t power minus 1 by t. So L t power minus 1, t power minus 1. So L t power minus 1. So the acceleration dimension formula is m power 0, L t power minus 1. If you didn't say m power 0 also no problem. So mainly you have to remember this one. So L t power minus 2. This is the dimension formula for acceleration. So in 10th class you might have remembered some physical quantities. Okay. So recall all those physical quantities and try to write each and every physical quantity you can write dimension formula. It will be starting here till second year end of the lesson. You can write for each and every physical quantity dimension formula. And first question any competitive exam they are going to ask from This lesson only means first question means any definitely one question they will ask from this units and measurements. So like this we can discuss 100 dimension formulas, 1000 dimension formulas because so many physical quantities will be there. So momentum. So what is meant by momentum? But till now in first period we didn't discuss about momentum. But you came to know already in your 8th, 9th, 10th class. What is momentum? Momentum is denoted with small p, isn't it? Momentum. So momentum is denoted with small p. What is the definition of momentum? Product of mass and velocity. Mass into velocity. Product of mass and velocity is called momentum. Now we came to know mass dimension formula. Mass dimension formula is capital M. And velocity L t power minus 1. Therefore L t power minus 1 is the dimension formula for momentum. Next, force. So what is the dimension formula for force? Force is denoted by F. What we can write F equal to ma. So m means capital M. Acceleration. Acceleration means L t power minus 2. L t power minus 2. This is the dimension formula for force. Up to now we are writing by taking the equation or definition. Now we can write the dimension formula by knowing units also. So if you know the unit, if you know the definition, if you know the equation, so you should come to know any one of these three. Then we can write the dimension formula very easily. Okay, so can you say any one unit which one you will be coming to know? So meter per second you will say. Meter per second. Now we are writing dimension formulas by taking units, not by taking physical quantities. Meter per second. So this is called meter per second. So meter per second is the unit for which physical quantity we will discuss that. First we are writing dimension formula for meter per second. Meter means which will be coming under, meter is the unit for length. Therefore meter means L per second. Second means second is the unit for time. Therefore so L by T. L by T means how we will write? L t power minus 1. So meter per second dimension formula is L t power minus 1. So L t power minus 1 is representing velocity. Velocity will be L t power minus 1. L t power minus 1 is velocity. Meter per second is the unit for velocity. So like the meter per second square. Meter per second square means that is for acceleration. You will get L t power minus 2. L t power minus 2. Now they will ask, write the dimension formula for Newton. Write the dimension formula for Newton. So Newton is the unit. Okay. So write the dimension formula for Newton means, so Newton is the unit for which physical quantity you should come from. Why? Because we don't know Newton is represented. Here meter per second is directly it is there in fundamental physical quantities, in terms of fundamental physical quantities. But Newton means this is not given in terms of fundamental. Therefore, Newton is the dimension formula for which physical quantity? Force. Okay. So force means F equal to ma. Again you will write m L t power minus 2. Next. If they ask, write the dimension formula for Pascal. Pascal is the unit, but this unit is representing which physical quantity unit you should come to know. Here Newton means Newton is the unit for which physical quantity? Force. Like that, Pascal is the unit for which physical quantity you should come to know. Pascal is the unit for which physical quantity? Do you know? So Pascal is the unit for pressure. How many of you remember? I don't know, it will be coming in your 10th class or 9th class. Somewhere you will get atmospheric pressure. You might have heard that. So Pascal is the unit for pressure. Therefore, pressure formula you should come to know. Here Newton is the unit for force. At the time what you got? Force formula F equal to ma, equation. Like that. What is the definition for pressure? Pressure means force acting per unit area. That is nothing but F by A. Force acting on unit area. So what is the force? Ma. Area. Area means L square. Already we got here L square. So force means, if you want to substitute directly, you can substitute. Force means ml t power minus 2. Remember this one. Force dimension formula so many times it will come. Therefore directly you can remember. So force dimension formula is ml t power minus 2 by L square. L square is going to numerator. L power minus 2 t power minus 2. L square is going to numerator power minus 2. Here 1 is there, 1 minus 2 minus 1. L power minus 1 t power minus 2. So this is the dimensional equation or dimensional formula for pressure. L power minus 1 t power minus 2 is the dimensional formula for Pascal. Dimensional formula for Pascal means dimensional formula for pressure. Now try to write dimensional formula for this unit. You can write easy. kg per meter cube. So kg per meter cube. Kg means kg is representing which physical quantity? Mass. Therefore m. Meter means length. Length cube is there. Therefore this is nothing but L power minus 3. This is the dimension formula. L power minus 3 is the dimension formula for kg per meter cube. Kg per meter cube is the unit for which physical quantity? Density. Therefore we got dimension formula for density. Have you got density? That is one of the physical quantity. Mass per unit volume. Isn't it? So I wrote some equations here which are familiar for you people. Like that. So many physical quantities will be coming. So from next lesson onwards, Newton's laws of motion, there you will be getting force, impulse and all this. Next lessons, work, energy, power, all these you will be getting. So which you are familiar, those I will try to write here. Whenever it is coming for competitive also, some second PU physical quantities they will give. Resistance, capacitance, inductance and all this. So those we will discuss, we can discuss in second year only. Here we can't discuss those because you can't understand. Therefore we did start this lesson first. Actually we have to start this lesson at first lesson. Why we did start means you should come to know some physical quantities. Okay, so all these are understanding on. Just you should come to know either equation or formula means definition or unit. If you know unit, equation or definition, you should be in a position to write dimension formula. You should not by heart. You can remember force ml t power minus 2 and remaining all area, volume. Just by using the equation on this part you have to write the dimension. Okay. Next, you might have heard joule. Write the dimension formula for joule means. Joule or erg there is. Joule is the unit of which one? Energy or work. Isn't it? Energy or work means what is the order? Equation. Force into displacement. You should come to my equation. Otherwise we can't write. Force into displacement. Force dimension formula. L t power minus 2. Displacement dimension formula. L square t power minus 2. L square t power minus 2 is the dimension formula for work done or dimension formula for joule. Another last dimension formula for energy. Energy means potential energy or kinetic energy. What is the equation for potential energy? It is denoted with U. U is equal to mgh. Why? Because those relations we are going to use in next topic, that is dimensional analysis applications of dimensional analysis. So U is equal to mgh. So mass. Capital M. G. What is small g there? Acceleration due to gravity. Acceleration due to gravity means that is equal to acceleration. So acceleration dimension from the L t power minus 2. Therefore L t power minus 2. H. H refers height. Height means that is representing length. Therefore, L. So M L square T power minus 2. This is the dimension formula for potential energy. Next, kinetic energy. Kinetic energy formula you came to know of mv square. Okay, so for this, what is the dimension formula? Kinetic energy Ke dimension formula is for half 1 by 2, that is constant. We won't write. Mass means capital M. Velocity. Velocity dimension formula. Velocity L T power minus 1. L T power minus 1 whole square. Therefore, M L square T power minus 2. This is the dimension formula for energy. So, work, energy, force, momentum, pressure, all these we wrote. Try to remember this. If you forgot means, try to write like that. So, we will see our next concept. Okay. So, next topic, dimensional analysis and its applications. So, what is the use of these dimensional formulas? That is only will be coming under applications. So, there are 3 applications. By using these dimensional formulas, what we will do? Dimensional analysis and its applications. They will ask, write any 2 applications, write any 1 application, or write any 3 applications of dimensional analysis with example they will ask. At the time, so this is 5 marks question, very important question. At the time, what we have to write, we will see. So there are 3 applications. They gave only 2 in our textbook. So therefore, they will ask always to write any 2 applications. Out of these 3, you can write first one to check the correctness of the equation. To check the correctness of the given equation. They will give one equation, whether it is correct or wrong, they will ask. That is the first approach. Second one, to convert from one system of unit to another system of unit. So, to convert from one system of unit to another system of unit. So, meter to centimeter. Meter to centimeter means meter is mk square, centimeter is cg square. Like that, force, Newton, dyne. So, Newton is mk square, dyne is cg square. Like that. To convert from one system of unit to another system of unit. Last one, to obtain the relation between physical quantities. So they will give 3 or 4 physical quantities. We have to bring the relation between those physical quantities. Obtaining means bringing or getting the relation between physical quantities. So these 3 are the applications. How they will ask means, write any 2 applications of dimensional analysis with example they will ask. So write any 2 applications means any 2 you can write, either first one, third one, first one, second one, third one, but you should give example also. How to take example? First we will see first one, to check the correctness of the equation or dimensional consistency they will say. So whether given equation is wrong or correct we will say. So first application. So for this, you should come to know one principle that is called homogeneity principle. So what is the homogeneity principle? According to this principle, the physical quantities, any 2 physical quantities either added or subtracted, they will be having same dimensions. Same dimensions means I will give this simple equation, z is equal to x plus y. Z is equal to x plus y means I added here 2 physical quantities, that is nothing but x and y, x plus y. So now according to homogeneity principle, x and y will be having same dimensions. According to dimensions, x is equal to y. In dimensions I am saying x is equal to y, and z is equal to x, z is equal to y. This is the homogeneity principle. So always we can either add or subtract two physical quantities which are having same dimensions, not multiplication. I am saying addition and subtraction. Either you can add or subtract two physical quantities which are having same dimensions. Always the physical quantities which are having same dimensions can be always either added or subtracted according to homogeneity principle. How we will be coming to this one means take one equation. So this one I am saying according to homogeneity principle, and this will be applicable for this one to check the correctness of the equation. In motion straight line we got one equation. V is equal to equations of motion. V is equal to u plus at. This equation correct or wrong? Already we came to know that the equation is correct, but we have to check according to dimension form. First we will see what is this v, final velocity. What is this u, initial velocity. What is this a, acceleration. T, time. So initial velocity or final velocity, that physical quantity is velocity only. Therefore, what is the dimensional formula for velocity? LHS L t power minus 1. Correct, only this one already we discussed now. Velocity dimension formula L t power minus 1. So either initial velocity or final velocity, u dimension formula also will be same because both will be coming under velocity one. Next, at. So what is the dimensional formula for at wheels? A means acceleration. Acceleration means L t power minus 2. T means time. Correct only? Acceleration L t power minus 2. Previously we discussed now only. T means t. So here 1 is there. Minus 2 plus 1. How much you get? L t power minus 1. So this is the dimensional formula for A. Now see here, in place of x what is there here? U. In place of y what is there here? At. Now u and at added. Why we added means because u and at will be having same dimension formula. See here, u is having L t power minus 1, at is having L t power minus 1. Therefore, if we added two physical quantities means those added physical quantities will be having same dimension. And this v is equal to u, v is equal to a. I am saying according to dimensional formulas. Dimensionally, all these will be same. Take another equation. Another equation means S is equal to ut plus of at. These are the examples. Any one example you can write. You can take this example or you can take this example. This is example 2 you can take. So in LHS what is the displacement? Displacement we are going to denote with L. Now ut and at square also you should get L only according to if this equation is correct. Because already we came from this is correct. Therefore ut dimensional formula you should get L. At square dimensional formula you should get L. We will see ut. What is u? L t power minus 1. What is t? T. Therefore, t power minus 1, t power 1 minus 1, 0. L t power 0. L t power 0 means that is equal to L. ut equal to L. S is equal to L. Therefore, these two equal. Now you see these two. Means equal means dimensionally equal. Next, half a t square. Half will not have dimension formula. So a means L t power minus 2. T square means t square. Therefore, again you will get half a t square is equal to L. Therefore, dimensionally this equation is correct. Dimensionally this equation is correct. Okay. Now, which one you don't know? That one I will give. V is equal to velocity. V is equal to root GH. Just I am giving one equation. Velocity v is equal to root GH. Okay. So is this equation next? Otherwise you can take root GR. What is G? Acceleration due to gravity. What is R? Radius of the path. R is radius. G is acceleration due to gravity. Is this correct or wrong? They will ask. So I gave already two examples. I am giving third example. What is V here? Dimensional formula for V, velocity L t power minus 1. Root GR, RHS. Root GR. is equal to root of acceleration due to gravity, means acceleration dimension formula. R means radius. Radius means that is going to represent length. So L into L, what you will be getting? L square t power minus 2. So L t power minus 1 whole square. Can we write? Both will be same one. Square and root will be cancelled. Therefore L t power minus 1. LHS is L t power minus 1. RHS is L t power minus 1. Therefore this equation is correct. Understood? So that is first application. So to check the correctness of the equation, any one example you can write. That is, now I gave you 3 examples. Out of these 3, you came to know these 2. After completion of first PU, you will be having so many equations like this. So therefore, any one equation you can take which is familiar, which is known for you very well. So you can say whether it is correct or wrong. Okay. So our next thing is to convert from one system of unit to another system of unit. This is second application of dimension analysis. One system to another system means already again 1 meter is equal to 100 centimeters. That is nothing but 1 meter is equal to 10 square centimeters. Like that, 1 kg is equal to 1000 grams, and 1 kg is equal to 10 kilograms. These two you will be coming from. Just we should give one example. So I am going to take one example for you. So first one example over. Now second thing is to convert from one system of unit to another system of unit. Example, 1 Newton is equal to how many dynes? 1 Newton is equal to how many dynes? Newton is the MKS unit, dynes is the CGS unit. So meter is the MKS unit, centimeter is the CGS unit. 1 meter equal to 100 centimeters, 1 kg equal to 1000 grams. Same like that, 1 Newton is equal to how many dynes? Newton dimension formula. Newton means Newton is the unit for which physical quantity? Force. Dyne is also unit for force, but dimensionally small changes will be coming. We will see that. So 1 Newton. So this one we are going to use formula N1 U1 is equal to N2 U. So N1 means here 1. N2 means we are going to calculate. So 1. So unit means dimension formula M1 L1 T1 power minus 2. What is this M1 L1 T1 power minus 2 means? Force dimension formula, Newton dimension formula. What we wrote Newton dimension formula? ML T power minus 2. Here we wrote 1 because it is representing MKS unit. Next is equal to N2. N2 value we should find. Dyne is also dimensional unit for force. Same like this one we will get, but in CGS. That is nothing but M2 L2 T2 power minus 2. So first we have to understand this one, how we wrote this one. Okay. So both will be same only, same physical quantities, but this one we wrote M1 L1 T1 power minus 2. Newton is representing MKS unit. Dyne is representing CGS unit. So mass in MKS unit. What is the unit? Kg. Therefore what we will write? 1. Mass means kg. Length means meter. Time means second power minus 2 is equal to N2. Mass means here what we will write? Gram. Length means centimeter. Time means s power minus 2. So these two will be cancelled. Can we cancel kg and gram? We can't cancel. Either gram should be converted into kg or kg should be converted into gram. So 1 kg means how many grams we said here? 10 cube. 10 cube grams. In place of kg I wrote. In place of meter, 10 square centimeter is equal to N2. So gram centimeter. So now gram centimeter will be cancelled. So 1 into 10 cube 10 square. 10 power 3 plus 2 is equal to N2. Now N2 is equal to 10 power 5. Now N2 value how much you got? 10 power 5. Now 1 Newton is equal to how many dynes? 1 Newton is equal to 10 power 5 dynes. isn't it? This is conversion of one system of units to another system of units, Newton to Dutch. Understood? Now try to do this one for you. I am giving homework. One joule is equal to how many earths? So this value you should carry. Try to do at home. Joule means you should take dimension formula of energy or work done. mL square T power minus 2. In place here m1 L1 square T1 power minus 2, m2 L2 square T2 power minus 2. Try to do like this, then you will get n2 value. How much you got, you can check. If you have taken this one you can take it as second example. Otherwise, you can write this example. Okay, example for second application is over. What to convert from one system of unit to another system of unit. Last one. To obtain the relation between physical quantities, they will give 3 or 4 physical quantities. They will ask what is the relation between those. This one also I am giving simple example for you. To obtain the relation between mass, force and acceleration. You came to know already the relation. So they gave obtain the relation between 3 physical quantities: mass, force, acceleration. So whenever they are asking like this is the example for third application. So whenever they are asking like this to get the relation between physical quantities, always first we have to take in LHS first physical quantity. What is the first physical quantity here? Mass is equal to or directly proportional to, because sometimes constants will be coming, is equal to second physical quantity F, third physical quantity A. So F power you can take X or P, F power P, A power Q. So we are getting some relation, P value, Q value. Otherwise you will take A, B, C also you can take, P, Q, R also you can take. That is our relation. Okay. Now write the dimension formulas. You should come to the dimension formulas. Mass dimension formula M. Force dimension formula M, L, T power minus 2 whole power P. Acceleration dimension formula L, T power minus 2 Q. So expand this one. M power P, L power P, T power minus 2P. Like that. L power Q, T power minus 2Q. So M powers, only M power 1, therefore M power P, L powers, 2 L powers are there, here L power P, here L power Q, therefore L power P plus Q. Next T power minus 2P minus 2Q. You got one equation. Now compare. Whenever you are comparing here M power how much is there? 1, here M power P is there, therefore P is equal to 1. Next, here L power P plus Q is there, but here L is not there. L is not there means we can take L power 0. Nothing is there means L power 0. Because L power 0 is 1. So now P plus Q equal to 0. P plus Q equal to 0. Already we came to P value. P value how much? 1. Therefore 1 plus Q is equal to 0. Then Q is equal to minus. You got P value, Q value you got. We have to find P and Q only. So if you use this equation also minus 2Q, here T power 0 you will get. That one is not required. Why? Because already you got P value, Q value. So substitute this P and Q in this equation. M is equal to F power P value how much? 1. Next, A power Q value how much? Minus 1. So M is equal to F by A. This one only we will write F is equal to M. You got relation between force, mass, acceleration. Like this, no equation you can take. Otherwise, any new equation also you can take. So that is our relation. Now try to do as homework for this third one. So what is the equation means? Check the here means obtain the relation between velocity, acceleration due to gravity and the radius of the earth. Now only I wrote already, just you have to obtain the relation between velocity, acceleration due to gravity and radius of the earth. How to take means just I am giving hint. V is equal to or directly proportional to, you can take G power A R power P. Otherwise G power P R power Q. Same like this you can try to do. You will be getting relation between V, G, R. Okay. So till now we discussed about dimension analysis. and applications. How they will ask this question for 5 marks means write any two applications of dimension analysis with examples. So one application, one example. One application, one example. This is for 5 mark question. Very, very important question. And last concept in this, limitations of dimensional analysis. This is important for 2 marks. Write any two limitations of dimensional analysis this class. Now only we discussed last observation, last application. We got relation between physical quantities. So if we got relation between physical quantities means first I am giving example, later I will say about that. After the relation between V, U, A, T. After the relation between V, U, A, T means U can't get relation V is equal to U plus AT. And if they give 4 or more than 4 they give means physical quantities, you cannot get relation. Whenever arithmetical operations are there, means addition and subtraction is there. And you cannot get relation S is equal to UT plus or UT. This plus symbol won't come whenever we are deriving. Minus symbol won't come whenever we are deriving. This is one of the drawback or limitation of the dimensional analysis. So whenever we can't get the relation, in the relation arithmetical operations are there, addition and subtractions are there. That is the first one. We cannot apply dimensional analysis to get the relations which are present arithmetical operations. That is the first one. Next, second one. So you came to this equation very well. T is equal to 2 pi root L by 2. So whenever 2 pi is constant here, if there is a relation between time period, length and acceleration due to gravity, then you will get relation only like this. It will not give information about dimensionless constants. Constants are dimensionless constants. So dimensional formulas or dimensional analysis will not give information. If they give kinetic energy, mass, velocity, then K is equal to half mv square. But you will not get information about this half whenever we are deriving the equation. Therefore, dimensional analysis will not give any information about constants or dimensionless constants. That is the second application. Okay, next one. So any trigonometric functions, logarithmic functions. Let us assume I give one equation. This equation you will get in SHM, simple harmonic motion. Y is equal to A sin omega t. This is one relation. Some relation otherwise A into e power ax. Another one A log x plus B cos x. This type of relation. So just I am giving example. This is called exponential function. This is called trigonometric function. This is called logarithmic functions. In the equation, these functions are there means you cannot apply dimensional analysis. So all these are the limitations. And the dimensional analysis cannot give the exact relation among the physical quantities. Okay, you will get, but exact relation we can't get by using dimensional analysis. All these are the limitations of dimensional analysis. Write any two limitations they will ask, and these are very, very important also. You have to remember whenever those are will be coming for competitive. So you will be coming to know how we are going to get these. Okay. Now this is the end of PU, units and measurements. So in this some problems will be there. We are going to discuss competitive problems. After discussing competitive problems, all PU problems you can only solve. Once you can see the dimensional formulas they gave in the first or second page of units and measurements lesson. They have given so many dimensional formulas, 50 to 60 they gave. But in the second year concepts also will be coming. You don't need to worry about second year concepts. Only first year what we discussed till now and what is important for you at present, what you can understand, those only I am going to explain from next class onwards. Okay, so within that time what you have to do means what we discussed till now, once you can revise, and any formulas are there means you can write it one place, and any physical quantities in your 10th class you will be coming to know resistance, voltage, current and all this, and heat energy, latent heat, all these formulas, specific heat, all these formulas, if you have known means from 8th, 9th, 10th or at least 10th class science textbook you can take. In the physics, which physical quantities you will be coming to know, once you can write at one place, then we will start competitive from next class onwards. Okay.